The molecular orbital diagram starts from the lowest energy to highest energy. The molecular orbitals take the electrons from the atomic orbitals and overlap. In molecular orbitals, we have bonding and anti-bonding orbitals. Electrons in the bonding orbitals will stabilize, while electrons in the anti-bonding orbitals will destabilize. We also form sigma and pi bonds in the molecular orbitals. Sigma bonds are always the first bonds formed between two atoms, while pi bonds are the second bonds of p orbitals. On our first example, we have N2-. First, we will fill the atomic orbitals of nitrogen. Next, we will fill the atomic orbitals of N-, which gains 1 electron. Now we will overlap the orbitals. First, we will start with sigma 1s and sigma star 1s. The star represents the anti-bonding orbital. Since we have 4 electrons in total, both the orbitals will be filled. We will do the same for sigma 2s and sigma 2 star s. Now we will move on to the 2p orbitals. Since we have 7 total electrons, we will start filling from bottom up, starting with the pi bonds. On our next example, we have N2+. Here, nitrogen will lose an electron. The s orbitals have the same overlap of bonding and anti-bonding electrons as N2-. However, for our p orbital, we will only be able to fill up to sigma 2pz. Now to calculate the bond order, we have to subtract bonding electron orbitals from anti-bonding orbitals and multiply by 1/2. N2 had 10 electrons in the bonding orbitals and 5 electrons in the anti-bonding orbitals, which will give us 2.5, while N2 plus had 9 electrons in the bonding orbital and 4 electrons in the anti-bonding orbitals, which will also give us 2.5. Since both species have less electrons in anti-bonding orbitals than bonding, they will exist. If they had more anti-bonding, they would be unstable. And since they have the same bond order, they will have the same bond length and same strength.